Good morning, everyone. I welcome you all to this session on industrial ready graduates. When I say industrial ready graduates, how can we make graduates coming out of universities or engineering colleges to be ready for the industry? How do we understand the gap that needs to be filled so that the graduates be placed well with a lot of opportunities coming in? So when I say a lot of opportunities coming in, we also have a notion that the technologies are already or always disruptive in nature nowadays, losing jobs. But let's put it into another way. It got an ample amount of opportunities as well. So here are some of the technologies which promises a lot of opportunities. To start with is artificial intelligence, machine learning, deep learning, natural linguistic processing, NLP, computer vision, CV, augmented reality and virtual reality. From an AI point of view, you have Vertex-AI, Gen AI, ethical AI, AGI, and computation. We have quantum computation, cryptography, quantum cryptography from a cybersecurity point of view, LangChain, the telecommunication, we have 5G, 6G, and CRISPR gene editor technology, which is more to do with DNA. So these are some of the emerging technologies which the world is going to see, and some are there already. So that's what we're going to be analyzing in today and how the graduates be made available or aligned with the availability what these resources, these technologies can dwell in. First and foremost, what's the ROI for a graduate? Obviously, it's knowledge and skills. The expectation of any graduate is from the universities to enhance one's skills so that they can be more they can have more opportunities or career opportunities. That's the second one. Accreditation and reputation, obviously individual, one of us would want to have reputation, and the personal development, both from personal, financial, as a 360-degree growth is what a personal development dwells in. So that's all with the amount of knowledge and skills a individual or a graduate can acquire. Now here, if you see here, there are two arrows here. The first one towards the left is the academy and the right is industry. How does the graduate in between, the industry and the academy gain the skill set so that they can be ready for the jobs which are waiting for them as and when they pass, without much of skills enhancement? That's what we are looking in for, right? So some of the gaps which I could jot down here is the resource availability. The first one, when I say the resource availability, what I'm trying to say is the industrial resources that can be made available at the academy level as well. What I mean to say is, can the academy, collaborate with industry experts who can guide them, to move in or look forward to understand the need of the industry. Yeah, so that's where resources are very important from an industry who can help academy, to look or have an insightfulness of the future. The second one is the advanced computation. There are a good amount of universities which lacks infrastructure from a computation point of view. Could be laboratories. So that's where collaboration can help industries to leverage its lab facilities to academy for a mutual benefit. Yeah. The slow technology adaptation. We've seen that the industry is very fast moving. At present times, we have researchers coming out of laboratories for every 60 minutes. We have one experiment which is or innovation which is coming out. So with that kind of fast pacing at the industry, the slow adaptation of the academy is not going to help. That has to be bridged. That's one more thing. How fast can I change as an academy to adapt to the need of the industry? Then the academic curriculum, obviously what we study or what we learn or teach our graduates are the ones which they're going to exhibit. Correct. So that has to be the latest one and has to be upgraded on a very regular basis. You see the speed at which the industry is changing, so that should be the speed at which the academic curriculum also has to be amended. Future insightfulness, obviously, if you do not know where the future of the industry is going, there's no point in teaching students with the technologies that are outdated, yeah, which is not going to help them, nor the university, nor eventually the industry. Now, let me put in some of the innovations. These are cutting edge innovations which have come out of the collaboration between the academy and the industry. The first one is a lithium ion battery recharge. This was from the University of Texas and Sony. Collaboration is what they came out with. Good one. One of the good innovations. Internet of Things surprised, like say the MIT Auto ID Labs in collaboration with Procter and Gamble is what, the innovation came out. Then we have the AI and ML, Stanford, MIT Tech with Google and Microsoft is where the way was laid towards AI and ML development. MRA technology, you have academic institute with Siemens collaborating. Then you have the TCP/IP, the US Defense Department of Defense, and the BBN Technologies were the ones which did collaborate to get the TCP/IP as an innovation and as a cutting edge technology. Quantum computation, good amount of universities collaboration with companies like IBM and Google are the results of quantum computation today. Understanding this, every country's ecosystem or the technical ecosystem can be enhanced, and one of the main reason is when you have collaboration. For example, here I've taken India as how the ecosystem of India can be enhanced by having collaboration between universities and industry. So one of the country's GDP can really be taken up to a very high level when you have collaboration, when you have new innovations, when you have new patents in collaboration with the university graduates and the industrial experts. Here are some of the countries which I have. These are the top 5 countries which have a couple of innovations coming out on a year-to-year basis: United States, UK, Germany, Israel, and India. India is in the verge of progress towards more of innovation and collaboration. When I mean to say collaboration between academy and the industry, it's just started. The run is started now. Let me stress a little on the little country that Israel, which is known for its technical advancement. And one of the technical success of Israel is significantly to its strong collaboration between the academy and the industry. Yeah, so that's Israel is known for to stand with a lot of technological evolutions. So this is where the collaboration is one of the main yardstick which help this country to move, to be very strong in technology. We all know that. Now, when we know that, the ecosystem, yeah. So when we know that so much of changes have to be made or gaps have to be analyzed, how do we understand what are the new ecosystems? Yeah, we need to understand. So as in today, I have jotted down a couple of technologies that are for the future 2030 2032 plus and beyond. And this could be handy for universities to align to start as a starting point for them to make sure that the gap is being worked upon for a better future of the university, as well as the need of the industry be understood better. Here, we always see that the technology comes with a disruptive motive. Yeah, the disruptive technology. But here, I would want to, put forward that disruptive technology with endless opportunities. Yeah, these are disruptive technologies. What are they disrupting? They are trying to disrupt the old way of working, coming in new ways. And if we are able to adopt with this new way of working, we have a lot of opportunities, especially the graduates. There's nothing to lose for a graduate. He has no experience, prior experiences working on an industry like an experienced person for the last 10 years who's working on. He need not, have to, relearn things. So here, a graduate, fresh graduate who can be aligned, there's a lot of opportunity for him, in the new ecosystem. So here are some of the cutting edge technologies which I would want to introduce. We started off with AI, ML, DL, deep learning. We have these in autonomous vehicles. Today we have technologies going to generative AI where we are trying to generate things. So until the AI, ML, and DL, it was prediction. We were trying to predict from the data set what we got. Today we can use good amount of probabilities like conditional probabilities to understand, or joint probabilities and conditional probability to understand or create new things. It could be a new text, it could be a new photograph, it could be a new 3D element, or it could be a new code. All this can be generated using generative AI kind of a technology. That's one thing. The Vertex AI, this is where we, or where we leverage the computational power which is on the cloud, and the LLM models availability. So someone would want to use both the computational power and the model available, on a quick project. This is where the Vertex AI would help him. The ethics AI, this is very important because ethics stands a cornerstone in the evolution of AI. And as far as the ethics are not considered, taken care of, it could be a misery for human beings, when this AI becomes much more powerful. So the AI system to align with the human values and the ethical principles of humans is what the ethics AI dwells with. The AGI, the artificial general intelligence, where tasks could be many. Yeah, so simultaneously a robotic, equipment can do a couple of tasks compared to, a narrow task where we had in a couple of years that, it could only play chess. So here it could simultaneously do many more activities at the same time is what the AGI facilitates. Then we have quantum computation. So we have the shift from a classical to a quantum computation, bringing in a lot of opportunities and cutting edge technologies in computation, increasing the speed of computation by quantum. So it's a shift from a silicon or a transistor based to a atomic based computation, which can leverage a lot of opportunities in different fields. It can leverage jobs as well. So that's a huge amount of potential of opportunities which the industry opportunities which can be aligned by the university. Quantum cryptography, the future of cybersecurity. Yeah. By 2030 or 2032, we do not see any of these securities which are available. All would be vulnerable to quantum, computers. So when that happens, the future of security is on quantum cryptography. The better we understand that, there's a lot of job opportunities there. LangChain, the LLM model that can interact with the external data sources and APIs. Someone would want to use an API, call an API and do his model. This is where the platform is. CRISPR gene editor. So this is where it can cut a DNA, it can silence a DNA. So what do I mean is if a person has a faulty DNA. Or a diseased DNA to that matter, it could be converted into a healthy DNA. So that's what we can do. We can convert it, we can silence it, we can nullify the DNA, or if a DNA, a particular DNA uh, 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 a particular DNA, exhibits a kind of attributes, and you do not want that attribute, that can be silenced. So that's a kind of evolution the CRISPR gene editor can, do. So we're basically trying to edit the DNA of the human beings. So that's the level where the technology can go. So understanding this, the only mantra which the academy and the industry can succeed, or the academy can succeed to a large extent, is where they can collaborate with industries. From a resource point of view, I'm summarizing the last slide. From a resource point of view, you have resources who can align the need of the industry with the academy. Projects can be aligned, the academic projects, the industrial projects can be aligned with the academic requirement. The infrastructure like laboratories can be availed from the industry by the university. The course curriculum has to be amended on a regular basis. As I did say, technology is evolving and changing very rapidly. What you see 6 months ago is not going to be the technology which is going to be today. So that way, the curriculum also has to be, amended on a regular basis. Bridge the gap of the new technology adaptation. So adaptation has to be quick. The academy cannot take long time sitting on an old technology to be adopted. It has to be quick, and as a whole understand the need of the industry on a regular basis. So these are some of the points where academy can really stand out, understanding the need of the industry. So with that, I come to the end of this session. And with this, we see that there is a lot of opportunity where the graduates from universities and colleges can avail with the cutting edge technologies of today and future. Thank you so much. I hope you all enjoyed this session and you have a wonderful rest of the day. Thank you.